Okay, now let's discuss our next material, that's cast iron. So recall in our um, in our topic on carbon steels that we have this arrow line for the carbon content, and the lower value is 0.15%, and right here is, let's say, 1.7%. So anything above, or anything above this upper limit is referred to as cast iron. But of course, there's just a limiting value right here, depending upon the text or references. Some says it's 2.4 or 2.14, or for others, it's just simply 2.0. Okay, so or 4%. Okay, so you just have to check that out. And for cast iron, it may contain other alloying elements, and its applications may be found in large gears, brackets, linkage parts, pipe fittings, and many others. Okay, so right here, let's check our link, what the cast iron looks like. Okay, so right here, there's a cast iron for bars, rounds, rods, or for tubings. What else? Special shapes, plates. Okay, so that's the typical. And for cast irons, it's further classified as gray iron, ductile iron, white iron, and malleable. Okay, so typical application for gray cast iron are engine blocks, gear, brakes, parts, and machine bases. And for white cast irons, usually that's for wear plates in machinery. Okay, so you just have to read this in our lecture handouts. So let's write here cast iron. Okay, now let's move on to our next material, which is the aluminum and its alloys. Okay, aluminum materials, they are characterized by their lightweight, good corrosion resistance, and relatively ease of forming and machining. Okay, so take note, it's lightweight, good, it has also corrosion resistance, and relatively ease of forming and machining. Okay, so the reason why it has resistance to corrosions is something like the same as the stainless steel, that in the exposure to environments, there exists a very thin film of aluminum oxide that quickly forms on surfaces exposed to the atmosphere. So somehow that becomes the protective layer. Okay, so in terms of available shapes, this material is available in sheets, plates, foils. Okay, so this foil is actually anything smaller than sheets. So recall that I mentioned about 6 mm value for differentiating the sheets and the plates. But there is also another value right here, and I don't remember exactly, but probably that's 0.15 mm, or I don't know. So anything below this value, that's gonna be the foil. Okay, so just think of foil as anything thinner, much thinner than the sheets. Okay, and aluminum products, they are classified as either wrought or cast. Okay, so this is not available anyway for the selected aluminum designation and their applications. Okay, so in this table, I have included uh, some some types or some designations of the aluminum and their I think they should be applications, right? Okay, so for example, 1060 aluminum that's used, or typical applications are chemical equipment and tanks, and for this type, this is aircraft structures, and for 5052, that's for hydraulic tubes and sheet metal fabrication, and things like that. Okay, so you can read that in our in our lecture handouts. Okay, now in terms of designations, the ones commonly used for aluminum is the aluminum association. Okay, and recall that for aluminum, it's classified as either wrought, or cast. Okay, so for wrought aluminum, the classification is something like this, which is somehow similar to the carbon steels. So we have a 4-digit system plus tempered designations. Okay, so for the first digit, that refers to the alloy type according to major alloying elements. So right here in the table, it has it shows here, like for example, the 1000 series. If it's 1, then it's an aluminum that is 99% or greater, um, uh, greater greater percent for aluminum contents. And if it's 2, then it has copper, and if it's 3, that's manganese, and so on and so forth. And for the second digit, it's a modification to one of the alloying elements. And the last two, this is actually arbitrary label of specific alloy except for 1000 series. Okay, so it's just arbitrary except for 1000 series. So for this one, for example, we have a 1050. That's a commercially pure aluminum because this is 1. And for the 50, that means that it is 99.5% aluminum. And for the cast aluminum, we have this designation. It's also a 4-digit designation, except that it has a decimal point right here. Okay, so this one is almost the same, except that for the 6000 series, this is not much used. And for these 2 digits right here, that's a particular composition of alloying elements, and the last digit after the decimal point is used to mark whether the aluminum alloy is a casting or this one. Okay, and if it's 0, then this is it. This is the meaning or the interpretation. If it's 1, then it's this form. And for the tempered designation, we can have F, O, or H, or T. Okay, so TX, meaning for the X stands for any arbitrary number, like for example T1, T4, something. Okay, now moving on to our next material, which is copper and its alloys. Okay, so pure copper is rarely used for machine parts because of its relatively low strength compared with its alloys. So most common alloy for copper is the brass and the bronze. When we say brass, it's a copper alloy with zinc. Okay, so copper and zinc. And when we say bronze, that is a copper alloy with tin. Okay, and let's check this link right here to see what it looks like. Okay, so for the copper, it looks something like a reddish brown, and for the brass, it's something like yellowish, and this is more brownish. Okay, for the bronze. Okay, and in terms of characteristics, coppers have superiority in terms of further processing, such as forming, machining, joining, and finishing. Okay, next one is the nickel and its alloys. So, another non-ferrous material, non-ferrous metal is the nickel. Nickel usually is an alloying agent with steel, to which it imparts corrosion resistance and strength. Okay, and nickel alloys are available in the form of plates, bars, sheets, strips, rods, and many other shapes. Okay, so right here, this is the link. So it has a nickel alloy pipe, fittings, flanges. Okay, and there are actually commercially available proprietary alloy types. Like for example, if it's an alloy of nickel and copper, it's called monel, and nickel chromium, it's called this one. Okay, so proprietary by this is it. International Nickel Corporation, or I don't know, maybe company. um, this is from our text. Okay, and if it's a nickel, molybdenum, and chromium alloy, a combination of these three elements, then that's this one, this terms, and by this company. Okay, and another one is nickel chromium iron alloy is a nichrome. Okay, nichrome material, which is high electrical and oxidation resistance, so used for electrical heating elements. Okay, moving on to the next material is next class of materials, the ceramics and glasses. Ceramics and glasses are another class of engineering materials that are brittle. Okay, typical applications are found in building constructions, but some types of ceramics and advanced ceramics materials are used in certain machinery parts. So right here we have the links for, let's say, ceramic brake pads. Okay, so here's the brake pads of an automobile. Okay, so this material is actually a type of ceramics. Okay, and we also have ceramic bearings. Okay, so we have here ceramic bearings. Typically, the bearings are steel. I mean, are metal materials, but there are also um, developments in terms of bearing materials, that there's also ceramic bearings because of the characteristics, or characteristics of the ceramic materials, which has a corrosion resistance, and also it can withstand high or low temperatures, and also it has electrical insulation, and also lack of lubrications. Okay, so whereas for steels, then you would need lubrications, and you would also have problems if the application is exposed to, let's say, high or low temperatures, and also the problem on corrosions. Okay, so there are advantages for these ceramic materials. Okay, another one is the carbides in cutting tools. Okay, so we have carbides, okay, precision solid carbides in cutting tools. Okay, right here in our presentation, there are typical ceramic and glasses materials. So we have clay, we also have silica, which is the basis for glass products, and we also have alumina and silicon carbides, so two abrasive materials used in grinding. Okay, so that's one type of ceramic materials. The typical example here is the grinding block and flattening stones. Okay, so that's a ceramic materials. Okay, other types are carbides, nitrides, and engineered or advanced ceramics. Okay, like for example the ceramic bearings. Okay, next one is the polymers. Another class of materials is the polymers and elastomers. And the main advantage is that they are easy to shape, and low cost in terms of materials, and low cost in terms of manufacturing. Okay, so right here, let's check here some types of engineering plastics. Okay, so we have these different types of plastics, plastic materials. We have extruded nylon, we have acetal, uh, polyester, cast nylon, PBT, and many more. Okay, so if you have observed that, um, let's say, you're previously in the design of backpack sprayer. Okay, so let's say we have this backpack sprayer. Okay, so traditionally the design of this backpack sprayer is it is constructed, or the material used is stainless steel. And nowadays, the backpack sprayer is constructed using plastic materials. Okay, so the advantage is that in terms of the material itself, I mean in terms of the cost, then probably this would, I mean, maybe not in the cost, but in terms of the let's say lightweight, all right, lightweight, lightweight material for the plastic backpack sprayers, then it's more lightweight. So that means it is much better than the stainless steel. In terms of corrosion, of course, for plastic materials, then it is not, or we can say that it is resistant to corrosion as well. Okay, and what else? In terms of manufacturing, or let's say cost of manufacturing, so for stainless steel, then you have to secure the joints right here. I don't know, maybe through seaming or welding or things like that. But for this one, this can be this can be manufactured in one solid construction. Okay, so moving on, polymers can be classified in many ways. So in terms of chemistry, or in terms of structure, or in terms of behavior. But in terms of behavior and why they behave and when heated up, they can be divided into category, three categories. So the first one, that's thermoplastics, another one is thermosets, and the third one is elastomers. By the way, let's check this link right here. Okay, so we have examples of the plastics. Okay, so for the thermoplastics, they are actually a type of plastics that when they are heated up, they are heated, formed, and then cooled in their final shape, and can also be reheated. Okay, so they can also be reheated because no chemical bonding occurs. Okay, so these are the types of plastics that they can be reheated. But for thermosets, they set in their physical and chemical properties, and after an initial heat treatment, and therefore they are no longer affected by additional heat exposures. Okay, so they cannot be reheated. Okay, so for elastomers, basically these are type of polymers that exhibit significant elastic behavior. So actually the rubbers, right? Rubbers. And right here we have many types of specific types specific types of thermoplastics or polymers right here. Let's say nylon, polycarbonate, PVC, polyamide, and things like that. And you can just check our past regarding the description of these types of plastics, engineering plastics. Now, in terms of plastic identifications, to identify consumer products made of plastics, the Society of Plastic Industry Incorporation has developed plastic container coding systems. Although other organizations like ASTM, SAE, and ISO, they have also proposed similar systems of identification. So using a single-digit number in a triangle. So you would notice this in some of the containers, plastic containers. Usually at the bottom portion, you will see a triangle, and in that triangle, there's a one-digit number. Okay, so if it's one, then that's if it is one, the plastic material is PET, polyethylene. If it's two, then that's HDPE, high density polyethylene, or if it's three, that's PVC. If it's four, it's this and that. Okay, and lastly, the composite. Okay, so composites, as I've said, that is a class of material consisting of two or more phases that are processed separately and then bonded together to achieve properties superior to its constituents. Okay, so let's check an example. By the way, a natural example of composite is wood. Okay, so right here we have it shows here a carbon fiber chassis. Okay, so imagine that if this is made up of metal, then this would be very heavy. But for carbon fiber, then it is lightweight. Okay, and the strength, then of course it can also retain the strength. Okay, another example is the wood plastic composites. Okay, so this one for structural applications or building applications. So it combines the it combines the properties of wood um, and and plastics. Okay, so if it is just purely wood, then the problem is in terms of moisture and degradation due to moisture. But because it is a combination of wood and plastics, then it becomes superior, or it can be applied to situations where there are high moisture or exposure to water. Okay, so that's all in this video presentation, and in the next video we'll be talking about the manufacturing processes. See you in the next video.